welcome back to another video. Today we have another mathematical topic, which is the normal distribution. Normal distribution is data that is distributed symmetrically around its mean, as you can see here. You might know it under the term Gaussian ones. So those are essential in statistical application. And normal distributions are commonly used not only in natural but also in social sciences. They can be widely applied to all sorts of variables in the, real world, which actually follow a normal distribution, like birth weight, height, and also marks. The formula is complicated and we don't want to discuss it in detail. Just let me say that it's for a probability density function. So where the area under the curve represents the probability. Don't worry too much about the formula. Now it's all about understanding the principle behind normal distribution. So to define any normal distribution, we basically need two parameters, which are the mean, which is in this case equal to the median, and the standard deviation. If you're not completely familiar with those terms, you might want to watch my video about basic statistical measures linked above, where those are explained in more detail. Now, the mean marks, let's say, the highest point of the distribution and determines where the center of the peak is. So if you vary the mean, the curve shifts along the x-axis. And the standard deviation is for the shape of the curve. If you have a large standard deviation, this results in a flatter curve, while it gets steeper for a small one. Now, mean and standard deviation actually apply to entire populations, and statisticians denote them with mu and sigma for a mean and a standard deviation, but as in reality those measures are unknown, we use x for the mean and s for the standard deviation. So just that you're familiar with the different terms. Now let's talk about the empirical rule, which describes the proportion of values that lie within a specific area of the normal distribution. If you take a look at the drawing, it might be easier to understand what I'm talking about. So 68% of all values lie between the mean and plus minus standard deviation. 96% lie between mean and plus minus 2 standard deviations, and 99.7% lie between mean and plus minus 3 standard deviation. You can also say it's the 68, 95, 99.7 rule. It might be used to get an overview of your dataset or also to determine the likelihood that a value is as high or as low as x. Now, when it comes to statistics, we're talking about the central limit theorem, which states that the sum of many variables will follow a normal distribution. So now we have two important conclusions from this theorem. So first, if you increase your sample size, it will approach the population mean, which you cannot calculate. And second, if you have a large sample, the distribution will become normal, even if it was not for your small sample size of the variable. When we're talking about tests that are applicable to normally distributed variables, we're talking about parametric ones. The others are called non-parametric. And now, if you want to compare, for example, different populations, you might want to standardize your normal distribution to a Z distribution. This means that the mean value is set to 0 and the standard deviation to 1. The formula is as follows, and now you get a z-score, which is a measure for how many standard deviation the respective value is away from the mean. It can also be applied to find the probability that a value is below this z-score, which is the so-called p-value, and this is an essential measure in statistics. Now, normal distribution is not only applied in statistical testing, but it's also essential for regression analysis, where the so-called residuals should be normally distributed. There are 2 separate videos about linear and logistic regression if you want to know more about those topics. I hope this video gave you a brief overview of this highly complex and essential topic. If you like this video, don't forget to give it a thumbs up and to subscribe to the channel to see weekly uploads. See you in the next video.